A while ago, I bought some Athern 40-foot pulpwood wagons, and some of them came with log loads, which look great. But unfortunately, some of the ones that I bought came without. So I decided I could make some. I can make a log load myself. But I cut a lot of logs, a lot of twigs to be assembled, stuck together into a log load, but that seems a lot of work. Cutting these was a lot of work, and cutting them to the same length was a lot of work too, even though I had 3D printed a former to allow me to cut to a reasonable approximation of the right length. But doing that was a lot of work, and then sticking them all together also seemed a lot of work, so I put those to one side and I 3D printed a log load. Now, these logs look a bit large, so I tried it again, and yeah, I think that that looks a reasonable job. And I've also developed it so that the log loads aren't all the same. I can customize the size of the logs so that no two loads are the same. I've actually painted these using one of my kids' watercolor sets. I think they came out all right compared to the original. When 3D printing, I like to prototype in white PLA, which shows the details, to my eyes anyway, better than any other color. And this was actually an old spool of PLA which had got a bit damp and started stringing and making a mess. I don't know if the camera can pick it up, but on the top, yeah, there we are, the layers don't join up smoothly, which actually in this case is useful, because what I want is to simulate a lot of pulpwood logs, not not a pile of PVC pipes. So that unevenness, if I can get it to focus, that unevenness, yeah, it looks a bit like detachable bark or detaching bark. And as I say, I've printed a few of these which are all subtly different. In fact, frankly, I printed too many, but there we are. That's prototyping for you. Now, the rest of this video is about software, the software that I wrote to develop these. So if you've got this far, thank you very much. If you're interested in model trends, that's great. If you want to see the software, hang about and I'll demonstrate how it works. If not, bye. As I have a software background, I like to design using OpenSCAD. That allows you to generate 3D models using a variety of fairly straightforward, simple 3D shapes such as rectangles, squares, cylinders, etc. In this case, I've defined a large rectangle and filled it with cylinders. So each of the cylinders represents a log, of course. In order to do that, I've defined an array which gives the x and y position of the center of the log and the radius of the log. I'll come back to how I actually generate this long list. There's one of these for each of the logs on the load. I'll show you how to generate that later on. There's a lot of code here which I don't think I need to go into today, but essentially what I'm doing is I'm generating that list of logs, putting them together in the right area, and then because sometimes I get gaps in the top, I'm adding a few logs up on top of the load just to fill in any holes. And I'm also carving out a hole in the middle because some of the wagons have a center beam which I need to work around. But there is one of the log loads I've designed. No, that was the easy part. The difficult part is that this takes quite a long time to render, but it's one of those jobs that you start it going and you go off and get on with your life. So let's go back to this list of log positions and sizes. And once we've got this list, it's relatively straightforward to generate the logs using OpenSCAD. The problem, of course, is how to generate a list of non-overlapping circles. If I look at this in 2 dimensions, what we want to do is generate a list of non-overlapping circles, which we can then use OpenSCAD to convert to cylinders. So, question is, how do we do that? And the answer is we use software. Again, as I say, I'm an ex-software engineer, and I'm going to use, in this case, Python. This is based on an article I found on Stack Overflow on random non-overlapping circles with circle number controlled in Python and Pygame. And I copied their code basically. Pygame is a really useful product for this, a package for this sort of operation. I'm not going to explain how the software works. I'm going to explain what it does. So I'm using Pygame to display the results as we run them. Um, what I want to do is generate a number of logs, but the way the logs fit together, I want to put the large logs into the load first of all, and then fill the gaps in between those with medium-sized logs, and then the gaps in between those with small logs. I'm hoping that that will then give us a complete full log load. So circle list will become the list of circles which I use here. So what I'm trying to do is overlay 3 different layers of logs, but in such a way that they don't overlap. Perhaps an example might be easier. Let me run this up. So here's the rectangle into which I'm trying to fit logs. The red circle overlapped with a previous log, so it was rejected. All the black logs will go into the final load. And this runs and runs. Again, I'm only demonstrating, I'm only displaying the last 5 rejected logs. Every time I reject a new one, the 5th oldest one gets deleted. As I say, this program just runs and runs and runs. I've got a running count of how many successful logs we've produced. This is just a demonstration. So I've limited it to 40 logs or thereabouts. And the full list takes a lot longer to run. This one took less than a minute. No, it felt longer than that while I was talking. And there is my list of circle, X and Y locations, and radius. So this is a full run. One of the problems that I have, well, one of the problems is that it takes a long time to run. Again, I've not designed it to be terribly efficient. I've just designed it to produce the end result. As you can see, the more circles that we actually add into the rectangle, the more difficult it is exponentially to find a position within them. Now I'm just doing this randomly, just so that it can be left running while it's trying to place these logs. Right, okay, so here we are nearly 2 hours later, and the Python has finished running. Here are the circles that have been fitted into the rectangle, or the logs that have been fitted into our load. It's here in graphical form, just as a bit of feedback that it's actually running. now that it's stopped. But here is what we really want, and that is the list of circle locations and sizes, which we feed back into here. Now again, because I'm loading circles into a rectangle, I can customize the length and the height of the log load. So, for example, there's the length of an Athern model, and there is one for an Eve model flat car, which is somewhat longer. Similarly, when I generate these lists here, I can customize the size of the circles, that is the diameters of the logs. So I can have a load of large logs or a load of small logs. And again, because I can reuse the circle list and overlay one layer on top of another, you can mix and match. And finally, there we have it. I should add a few notes on here. It took 2 hours for the Python to run, but once that had executed, I had a list that I could then feed into OpenSCAD. OpenSCAD then took another just over an hour to render, and then I had to 3D print it. Now, printing 2 of these at a time, side by side, takes about 8 hours on my Creality 3, what is it? Creality Ender 3 V2. Again, as I say, it's one of those projects where you kick it off, you start it running for each of the 3 stages, and you just go on and get on with something else, which I find is all right. Saves me gluing sticks together. Well, if you've got this far, thank you very, very much. The software, once I get myself GitHub account and get that set up, I'll put the software up on there, and I'll put a link in the comments below. Thank you very much, and goodbye.